right. Today, I feel, to some degree, now I could be wrong because everyone's different, but to some degree, today may not be as difficult as yesterday because we're not really dealing with words. Some people love words in math, some people don't. This stuff, 3.7, solving linear inequalities. This is doing exactly what you've been doing, but we're just adding a little something to it. We're going to be doing intruder alert today. We're going to be simplifying, combining like terms. We are going to be doing intruder alert. You're going to be solving for something. But this time is going to be a little bit different. In this chapter, most of the chapter, you're solving for one letter. That letter, X, is going to be one number, right? X equals 2. X can only be 2. Y equals 14. Y is only going to be 14. Well, today we're talking about inequalities, okay? Inequalities, raise your hand if you even remember what an inequality is. Okay, perfect. So glad nobody has their hand up.
Why?
Okay. Inequalities are basically less than, greater than, less than equal to, greater than equal to, and then we're going to sometimes have does not equal.
What about equal?
Well, that is more of what we've been doing.
I have a question.
Yes.
I forgot what greater than equal to, less than equal to are.
Like something is less than, okay, we'll talk about that in just a minute. Okay, so this one right here is less than or equal to. This is greater than or equal to. So inequalities are these. All we're doing today is replacing the equal sign that y'all have been doing with really one of these right here. Because instead of having x equals 2 by the time you solve it, isolating the variable, it's going to be x can be any number greater than 2. So it can be many different numbers, okay? It's not now, this section means that x or y or whatever letter or u, it's going to be many different numbers, not just one. Okay, the first little tidbit that we need to learn is how to graph it on a number line. Graphing on a number line. Now we are dealing with this. Okay, this is important information. Open circle is used for greater than or less than or not equal to. So open circle is used for greater than or less than or not equal to. Trust me, I'll give you examples.
Is equal to an inequality?
I'm going to show you examples. Equal to, yeah, we use that, but not very often. This is for when we're graphing. 2, closed circle is used for greater than or equal to, or less than and equal to, or equal to. So we're going to use a closed circle on the number line if our problem has this, has one of these. So open circle on the number line if it's one of these, closed circle if it's one of these. And I'm going to start giving you examples and you're like, oh, okay. You're going to then shade the number line in the direction that would include all the numbers that X can represent. So then you shade the number line in the direction that would include all the numbers that X can represent. And then I'm going to start doing examples of just this part. We'll see how much we get through today. Maybe moving your test back a day. It says to shade the number line. My students like another method I'm going to show you in just a minute. Got it, Kelly?
Yeah.
All right, let's start doing. These aren't from your book. These are just going to be examples to explain what we're doing today. Okay, for example, let's say I gave you a big equation. You had to solve for X, intruder alert. And you got X is greater than 4. Now look at that for a second. What we've been doing is X equals 4, correct?
Yes.
Okay, that means X has the value of what? 4. If we say X equals 4, that's saying X is 4, right? Now it says X is greater than 4. That means X can be any number greater than 4. X can be 4.5. It can be 5. It can be 6. It can be 100. But with inequalities, it's saying X can be any number as long as it's greater than 4. Can it be 4?
No.
No, because it does not say greater than or equal to. Tanner, did you see that? Can X be 4? No, because it says X is greater than 4. If it was X is greater than or equal to 4, that means X could be 4 or any number greater than. Okay, that's the difference. When we graph on a number line, watch how I do my number lines. You guys are in pre-algebra. You are done with 1, 2, 3, 4, 5, 6. You're done with that. You're big kids now. It says X is greater than 4. You should have a positive 4 and a negative 4. You don't need to put all the other numbers on there. That's wasting time right now because you guys know this. Now, look up here. This is important. Look at this sign. Am I going to have an open circle or closed circle? Raise your hand. Tanner?
Open.
Open. Open circle has these signs, and there it is. So open circle. That is a positive or negative 4? Positive. So I'm going to put my open circle above the 4. And it says shade the number line in the direction that would include all the numbers that X can represent. So it says X is any number basically greater than 4. So am I going to shade this direction or this direction, Atalia? Why to the right? Bingo. Now it says shade because they want you to put an open circle here and then shade. My students like doing this instead of shading.
I just did that.
That's what we did last week.
Okay, excellent. That's how it should be. Now, the biggest mistake kids make is not whether you use an open and closed circle. It's which direction to go. They just get confused. And you need to ask yourself, X is greater than 4, and think of some numbers that are greater than 4. And have that arrow go in that direction. Tanner, are you okay?
Yeah, got something to throw.
Okay. Drink your drink then. All right. But you need to get rid of it too. Okay, any questions about this so far? Okay, let's do another one. X is any number less than or equal to 4. Any number less than or equal to 4. Can it be 4?
Yes.
Yeah, because it has that equal sign there. But it can also be any number less than 4. So I have my 0. We're dealing with 4, so I have a 4, and I have a negative 4 to indicate the positives and the negatives. Joseph, closed or open circle? Do I have it over the positive 4 or the negative 4? And which direction is it going, Madeline? There you go. Because it says less than. Excellent.
I've noticed that just depending on which way that like weird triangle looking thing is pointing, that's the direction.
Okay. Every student says that. Be careful. Don't always rely on that. Because it sometimes does not work. And we're not going to go into instances when that is, but I need you just to double check. If it's like, okay, it's pointing this direction, so I'm going to go that direction, but let me just make sure, think about it before you do that. Okay? Now, why open and closed? This, it's open. So that's saying we're not including the number 4. It's open. It's hollow. It's saying we're going to start at the 4 and go this way, but we're not going to include it. That's why it's open. Closed means you are including that number. Okay? All right, let's do another. Every time. Oops, let me pause the video. Okay, here we go. Okay,
You shut off the fire door part, right? No. Okay.
it's still in there.
Yes.
All right, here we go. X does not equal 2. All right, so we have our 0, we have our 2 and negative 2. Kelly, open or closed circle?
It is, so that one is a closed circle.
Does not equal.
I put a hashtag there.
Okay, does not equal, and it's an open circle. So we're going to put the open circle, that's a positive 2. We're going to put it over here. Now what that's saying is that x can be any number. But what, Atalia?
But 2.
That's right. It can be any number on the number line. But the only one it can't be is 2. So which direction, Talia, am I going to be doing my arrows? Both ways, because it's any number on the number line but 2. All right. Any questions about that? Yes, ma'am.
This is all we're going to be doing today.
Oh, I've got more stuff. But this is I'm about to show you another one, okay? Do you have a question about this? All right.
Why does it matter if we have an open and closed circle?
Because one, open means you're not including that number. Closed means you're including that number. Okay. 14 greater than x plus 9.
Ooh.
All right. Now look here, guys. Y'all been doing this stuff. This chapter. You've been doing this stuff, right? The only thing that's different is this right here. We had been using an equal sign right there, but now we're doing inequalities, so we've got that sign. But we still have to solve for x. So, Atalia, how do I isolate the variable? How do I solve for x?
You subtract 9 from 14 because the opposite.
Because we treat this like an equal sign. When we move numbers and letters across the equal sign or the inequality sign, we have to perform the opposite, okay? Even if it's an inequality, we still treat it the same. So this is plus 9, so we're going to do the opposite. 14 minus 9 is?
5.
So 5 is greater than x. 5 is greater than x. So I have my number line. I have my 0, and I have my 5 and my negative 5. Madeline, once you have this written down, open or closed circle? Huh? Open, because the inequality does not have an or equal to thing here. So this is an open. It's a positive 5, so I'm going to put it right over there. So this is saying x can be any number less than 5. So which direction does the arrow go?
Oh wait, less than 5.
See why I said that's this?
I thought you said more than 5.
No.
I thought I heard more
Okay.
than 5.
This right here, remember when you said, I'm just going to go in the direction? This is this right
I heard
here.
you say more than 5.
So, but this again is why I said be careful with that too, because the x is on this side. So x is any number less than 5. So which direction, Madeline? To the left. Okay. So it's saying x is any number less than 5. Okay? So the arrow would go that way. Good job. Any questions so far about what we're doing? All right, I'm about to blow your minds. 3 stars. 3 stars. When multiplying and or dividing by a negative, you must flip the inequality sign.
How would you do that?
I'm going to show you.
Gibberish. I'm sure I used it in English.
These are key words. When multiplying and or dividing by a negative, you must flip the inequality sign. And I'm going to show you that. The key word by a negative. If you're multiplying and or dividing by a negative. Common mistake in students, every time they see a negative sign and they're multiplying, they flip the sign. No. If you're multiplying and dividing by a negative. For example, five plus x over 8 is less than 4. Joseph, what do I do first? It's intruder alert. We're isolating. We want to get x all by itself. So what do I do first? That's right. So we got to get rid of the first intruder. So we're going to subtract 5 on both sides. And I'm left with x over 8 is less than negative 1. Madeline, what do I do now? No. Are we multiplying or dividing by a negative? Okay. What do I do? Huh? Okay, but I have to get rid of the 8, right? How do I do that? That's right. Multiply both sides by 8. Now, question. Am I multiplying by a negative? What is 8? 8's positive. So am I multiplying this negative 1 by a negative number? Then there's no flipping of any sign.
That's confusing.
Oh, yeah. We're multiplying, but we're not multiplying by a negative.
But negative 1
Doesn't matter.
Unless the number you're multiplying by is a negative.
That's right. If you're multiplying or dividing by a negative, that's when you flip it. We are multiplying this negative 1 by a positive. So because that is positive, so no flip. That is positive, so no flip. Now, make sure you have that written down. Yeah, we can. Okay, open or closed? Over the negative. So, Madeline, which way does the arrow go? Huh?
I mean, no, that's wrong. I don't do
Well, you better before you start driving. X is any number less than negative 8, so it would go this direction.
I don't understand how people have problems with their left and right.
Oh, you'd be surprised. It happens.
I forgot. How do you tell which way we're going?
Okay, X is less than. So then what number is less than negative 8? You can say negative 9, blah, blah, blah. Okay? All right. Look at this example. Negative 5 plus 7 minus 8 plus 4 is greater than negative 5x.
This is a lot of work.
Stop crying. All right. What's the first thing I'm going to do? Raise your hand. Tanner?
The negative 5 plus 7.
Is what?
Negative 12.
Negative and a positive. The signs are different.
Oh.
What do?
Subtract.
And keep the sign of the,
Larger number.
so this would be
12. Three. I can't do math.
what's 7 minus 5?
2.
So it's a positive 2. I'm going to rewrite my problem. What's the next thing I do? Someone else. Natalia,
You add 8 and 4.
what do you get?
12.
So I'm going to rewrite my problem. 2 minus 12 is greater than negative 5x. Someone else, what do I do? Raise your hand. Kelly?
Then you minus 2 or 12.
2 minus 12, and what do you get? Huh? What sign is the 2?
A positive.
What sign is the 12?
A negative.
So then your answer is?
Negative 10.
Negative 10. Rewriting my problem. All right, Joseph or Madeline, what do I do now? One of you better step up. Joseph?
You add 10.
I have negative 10 over here and negative 5x over here. We're trying to solve for x. So what's the intruder? What?
5.
Negative 5, right? So how do I get rid of the negative 5?
Divide by negative 4.
We're going to divide both sides by negative 5. Does everyone see that? Because if negative 5 and x are being multiplied together, the opposite's division. Oh, wait a minute. I am dividing by a negative. It doesn't matter about that 10. This is what matters. Look again over here. It doesn't matter about that negative 1. We were multiplying by a positive. Here, we are dividing by a negative. Do y'all see that now? So negative 10 divided by negative 5 is what, Madeline? Negative divided by negative is a? And because we're dividing by a negative, the sign flips. And there's our answer. Look at the sign. It was greater than. Now it has changed because it's flipped because we're dividing by a negative. Natalia.
So, because
Okay, so what if we were multiplying or dividing by negative earlier in the problem?
Nope, it's right here at the end. Good question. Right. That was a good question. She goes, what if it was like way back up here that we were multiplying or dividing by negative? It's right here at the end. Okay, that matters.
I didn't know what you got to the end.
When you're about to isolate the variable, when you're down to one step. You had a question?
Would you do the number line?
Yeah, you can do the number line. We can do that.
Do we have to?
Let's just do it for practice.
But like I'm not like I'm. Would we have to?
No. Only if it tells you in the directions to. That is your answer. Open or close circle, boys and girls?
Okay.
Which direction, Madeline, does it go?
Right.
Very good. X is greater than 2. X is any number greater than 2. So it goes right. Good job. Any questions?
Yeah. Because I'm thinking the arrow is going the direction of the 2. Like, the 2 is less than.
It is less than X.
Yeah, I know. It's just I'm not.
I know this.
I understand it. It's just confusing.
Okay, so let me just tell you, okay, it is confusing. Knowing which direction the arrow goes is my students' biggest challenge next to knowing when to flip it, okay? Let me tell you, for algebra, algebra 1, algebra 2, etc., if you get confused here, but you get this, you are good to go. You are fine. Very little of this, you will see a lot of this. So if you have this mastered, you will be perfectly fine. You're going to have to know some of this. Like I'll have a couple questions on the test with that, but most will be this right here. And yes, even on the PSAT, SAT, they will have stuff like this. Okay, so you need to understand intruder alert. You need to understand how to solve for a variable. That is huge in the world of algebra. You'll see it over and over again in high school too, and even in college. You need to learn how to solve for the letter. That's huge. Be it an inequality or whether you're just doing with an equal sign, okay? So master this. Don't stress over the number line as much. This will not get you through algebra. This will get you through algebra. Now, common mistake with my students. They are so focused on performing each move correctly with positives and negatives and distributive properties and doing the opposite to move things back and forth that you guys are so focused on that, you will forget sometimes to flip the sign. It happens because you're so focused on doing all this correctly. Okay, so make sure you go back and check your work when doing inequalities. So inequalities, it's the same thing that y'all been doing, except for this right here, when you have to flip it. Now y'all are going to see the ones with the equal signs as, I wish I could go back and just do those, because there's less rules, right? All right, y'all will get there because we're going to do a lot of practicing. We're going to stop there for today. Okay, tomorrow you're going to come in and we're going to do examples in the book, and then I will set you free and I will just bump your test. Okay, so this will be